minus 2a squared minus 6a minus 8. And then I just have to combine terms and simplify my a squared terms. I'm going to get minus a squared, my 5a term and 6a, I'm going to get minus 6a, or minus a, and my 8 and negative 8 cancel out. So there's my final answer. So a lot of tedious work. You just got to be really careful to not forget anything. Okay, so we're going to be looking at graphs of polynomial functions. And we're going to think about how each type of function looks like if you graph it. Now you're familiar with the very first three here. We've done a lot of these. So the first function is, think of that as an x to the 0 power. In other words, this first line here is as if it's x, or it's like y equals 3, for example. Y equals 3. Well, y equals 3 times x to the 0 power, because x to the 0 power is 1. So that first function is x to the 0 power. And then the second function is x to the first power, or that's just a linear function, so like y equals 4x. And then the third function is what we've just been graphing last chapter. That looks like a quadratic, so it's going to be some sort of function of x squared. And you start to see the pattern. Then the next one is going to be a function of x cubed, and then x to the fourth and x to the fifth. So we would say that each of these has a degree, which is the exponent that you raise in the x. So a third degree cubic function of degree 3 looks like this. Okay. Now, one of the things we can figure out, which each of these functions, is how many times can it possibly cross the x-axis. And that's going to determine how many possible roots you could have for that type of function. So in the case of a degree equals 1, or x to the first function, you can see that it's going to cross the axis exactly one time. And it will always cross it once. So you're always going to get one solution for a linear function. Now the second function, a second degree function, that could cross the x-axis as many as 2 times. So the maximum number of roots you're going to get there is 2. So you can see those there and there. So the max number is 2. Now, you know that in the case of a quadratic function, you might get no real roots. In fact, the parabola might cross up here, in which case it doesn't cross the axis and you get no roots. But the maximum possible is 2. Okay, so let's look at the cubic function now. The cubic function, in this case, is going to cross the axis in 3 places. So you start to recognize the pattern. The degree of the function is going to tell you how many possible times it could cross the x-axis, how many possible real roots you could get. Now that's the maximum. You might get fewer depending on where the function is situated. If you slide the function up or slide it down, you might capture more or fewer, not more. The max is 5 for the 5th degree, max is 4 for the 4th degree, so you're not going to get any more than 4. But if you slide the function down, for example, you're going to get fewer than 4, so you could have less than 4. Okay. The number of zeros in an odd degree function may be less than the maximum by a multiple of 2. Okay, all that means is if you move this function so that it crosses the x-axis in more places, okay, so if I move the axis up to there, if that's the new x-axis, I'm going to get 1, 2, 3, 4, 5 different real roots. But where it is right now, okay, this is my new one. Like that's the maximum possible I get is 5 roots. But if it's actually where it's located right now, I only get 3 possible roots. If I were to slide the thing down further, I'm going to get only 1 possible root. So the total possible roots I could get are 1, 3, or 5. Or in other words, the maximum is 5. You can get less than that by a multiple of 2. So 5, 3, 1. All right, so this is a chart of all the possible end behaviors of a polynomial graph. And I'm not going to go through it right now. You need to have it in your notes, studied in the textbook, but I'm going to show you some examples and see what's going on. The idea here is that depending on the kind of function you could have an even function. Let's do that a different color. You could have, let's see, purple. You could have an even function, or you can have an odd function. Even or odd means like x squared would be even, and x cubed would be odd. So the degree is determined by the exponent. So if you have an even function or an odd function, okay? So if you have an even function and you have a positive leading coefficient, then these little descriptors will tell you what's going on with the end behavior. What does that mean? Well, I'm going to give you some examples in just a second. But here's a chart that you can refer to later when you're trying to remember for what different degree and leading coefficient will give you what kind of end behavior. Okay, so let's give some examples and hopefully it makes sense. So, the leading coefficient is going to determine your end behavior. All right, what is a leading coefficient? The leading coefficient is the coefficient in front of the highest order variable. So in this case, it's going to be x squared. I'm going to give you a different example. Let's try 3x squared plus 2x minus 4. In this case, the leading coefficient is 3. Okay, so you'd say that's a leading coefficient of 3. It's positive. The degree of this function is going to be 2, so it's a second degree. So for the function we're given here, though, the leading coefficient is 1, which is positive, and then the degree of this function is 2. Okay, so it's a second degree function with a positive leading coefficient. So what is the end behavior? What that means is what's going to happen at the as the graph goes on forever. What is happening? Okay, so we know that this is a quadratic. There's no negative coefficient, so it's going to open upwards somehow. We don't know exactly where it's going to cross the axis. We don't really care, but we want to know where is it going to end up? What is the end behavior? So what we're asking is, here's imagine our parabola. If we have the x-axis, and then f of x is the function. So as x approaches negative infinity, okay, so as x approaches negative infinity, that means as x goes from 0 to the left, then what is happening to the function? Well, the function is going to go up, 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 and away, and it's going to go closer and approach positive infinity. So the function itself is going to go up to positive infinity when the x value here goes to negative infinity. So x goes to negative infinity, the function itself is going to go to positive infinity. So you would say the end behavior is positive infinity. Now what about as x approaches positive infinity? So as it goes from 0 positive this way, what's going to happen to the function? Well, it's going to climb still, again, up, 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 and away, and so its end behavior when x approaches a positive infinity is also going to be positive infinity. Okay, so this is an even degree function. One of the cool things about even degree functions is wherever they start, in other words, this one's going to start way up here in the positive positive range, it's going to also end in the same place. So that's what even functions do. They start and end at the same side, essentially, of the x-axis. So whichever side it starts on, it finishes on. That's what happens with even degree polynomials. Okay, let's look at another one. Minus 3x to the fourth plus 1. Okay, we have another even degree. Okay, that's an even degree function. But this time we have a negative coefficient. Okay, so what happened with a negative coefficient with a parabola? It turned upside down. Okay, the same thing is going to happen with any even order polynomial. Okay, so if I were to graph this thing, it might look something like this. Okay, kind of funky, looks like an upside down W. Because it's negative, that means that it's going to open downwards. Okay, and then it's going to cross the x-axis up to 4 times maximum. Okay, so that's not exactly the graph, but that's the idea of what it looks like. So now you want to say, well, what's the end behavior of this type of a function? Well, as x approaches negative infinity, so it's going from 0 to the left on the x-axis, what is the function doing? Well, the function itself is now falling off to negative infinity. So it's going down, 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 down to negative infinity. So we say that as x goes to negative infinity, f of x also goes to negative infinity. Now what about as x goes to positive infinity? Okay, so if x is going to the right as to positive infinity, the function is still going down, 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 down. So we'd say it has f of x is going to approach negative infinity as well. So again, oops, let me go back. So again, we have an even function. It's going to start and end on the same side of the axis. Okay, that's what even functions do. This one has a negative coefficient, which means that it opens downward. Okay? All right, let's look at an odd one. So here is an odd degree, okay, up to the third power, and it's a negative coefficient, negative 1. Okay, so what is this thing going to look like? If you want to graph this function, it would look something like this. Okay? It's going to start way up high on the left, and it's going to go downhill to the right. Okay, that's what a negative coefficient will do to your odd degree function. Odd degree functions start and end on opposite sides of the axis. So we start up here, starts up here, and it's going to end up going down here. So it's going to go, they're going to start and finish on opposite sides of the axis. That's what odd functions do. Now because this is negative, negative ones tend to go downhill after they do a little, humpty bumpty boop. Right, there's the bump, okay? So it's going to end up going downhill. Just so you know, a positive function is going to work its way uphill, okay? So what about the end behavior for this particular function? As x goes to negative infinity, sorry, it's writing little notes, start high and end low, okay, let's keep going, odd degree, ends up opposite side. Okay, that's what I just said. Okay, so as x goes to negative infinity, so as we're going to the left again, what does the function do? It climbs up, 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 and it's going to say that f of x is going to approach positive infinity. So that's the end behavior for this function for x is going to negative 8. Now what is it about as x goes to positive infinity? I said 8, I meant infinity, sorry. As x goes to positive infinity, then f of x, okay, as x goes to positive infinity, f of x is going to go down, 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 down. So it's going to approach negative infinity. All right, let's keep going. This is a pretty simple function. You've seen this one lots of times before, x plus 2. That is a positive coefficient, and it is an odd degree because it's x to the first power. So that means it's going to start at one side and go to the other, and it's going to go uphill because it's even. Okay, so as x goes to negative infinity, it's going to drop down, go down, 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 so it's going to approach negative infinity. And then as x goes to positive infinity, as x is going to the right, then the function is going to go up, 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 or it's going to approach positive infinity. Okay, so here's a couple of examples we'll take you through. Let's figure out if we have this function here, part A, describe the end behavior. What we would say is, as x approaches infinity, the function is going to approach negative infinity. It's going down, down, down. As x goes to negative infinity, or to the left, the function goes down, 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 or minus infinity. Determine whether it represents odd degree or even degree. Well, because it starts and finishes on the same side of the axis, okay, so it starts and finishes on the same side, we know it's even, and so we'd write that. And then finally the number of zeros, well, how many times does it cross the axis? That's easy, 1, 2, so twice. Finish the writing, come on. 1, 2, 2 real zeros, okay? Letter B, let's take a look at that. As x approaches infinity, it goes to the right, the function goes up, 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 or approaches positive infinity. As x goes to negative infinity, f of x goes to positive infinity again. This is also an even function because it starts and ends on the same side. So it's an even function. How many real zeros? In this case, none, because it never does cross the x-axis, so no real zeros. Okay, last two examples. Describe the end behavior. All right, well, as x approaches infinity, so we're going to the right, then f of x, the function is going to climb up, 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 so it's going to go to positive infinity. As x goes to the left to negative infinity, then f of x, the function, is going to drop down, 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 so it's going to go to negative infinity. That's the end behavior. Is it an odd or even degree? Well, it starts on one side and ends on the other, so that's got to be an odd degree function. I'd also point out that it is a positive function. The coefficient is going to be positive because it starts left and goes uphill. And then finally, how many zeros? Just one, because that's the only place it crosses the axis. And last one, 4b, is the end behavior. As x approaches infinity, looks like it's going to drop off and go down, 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 down. For the right you go. As you go to the left, then x is going to go up. So x is going to go to, f of x goes to positive infinity. What is the, is it odd or even degree? Well, it ends and starts on different sides of the axis, so we know it's an odd degree. In this case, I'm guessing it's a negative coefficient because it's going to be going downhill, so that's a negative coefficient. And then finally, how many real zeros? 1, 2, 3. And that's it. We're done.